All right, let's do some graphing today. Notice in this one note here, I'm putting both 9.3 and 9.4 together. So 9.3 are the graphs of the sine and cosine functions. 9.4 are all other trig functions. But everything, as we talked about before, everything is based off of sine and cosine. So then it's a good starting place. So 9.3 is sine and cosine, which is where you're going to do most of your graphing, is where we're going to focus on. And then it's good to know tangent, cotangent, because they're a little bit different. Anyway, we'll get there. So first thing we want to talk about are the graphs of our sine and our cosine function. So let's write this out. The first thing we're going to talk about is sine. So in our sine function, so I'm just going to make a little graph here. The kicker to our sine function is I'm going to come up here to 1 and down here to -1. Make this bigger so that it's easier to see. Keep in mind, if I make these sine and cosine functions are called periodic functions. A periodic function is something that keeps happening over and over again. So for our sine function, this is the sine wave. It's just going to keep going over and over and over again. So once we talk about this periodic function, we're going to kind of break it down, but just know that it goes on forever. However, so I kept 9.2 notes up here because I wanted to be able to pull up our unit circle. When I have our unit circle, we have our values of our sine function here are all the y values, right? So I'm swinging around. A full period is one full loop around that unit circle. So whenever I set up my units here, I'm going to go with pi over 2, pi, 3 pi over 2, and 2 pi, just to give us an idea about what we're looking at. Your x-axis, if you will, here that I'm looking at is actually going to be our angle measurements. So that's going to be our angle measures that we're looking at. My output here is going to be, because this is sine, are going to be the y values. All right. So if I have y equals sine of x, right? So what is my output value? If I input an angle measurement here, what is my output value? Not just because it's a sine, but just because my output value are going to be the y values here. So that's my output value. All right. Okay. So what is the deal? If I have sine of 0, because that's where we're starting right here, at sine of 0 degrees, what is my value? It's also a 0, right? And pi over 2 is my next one. What's my value here of sine? Is a 1. Pi is a nice one. What is my y value? 0. Do you see where we're going? That's why we have these 3 pi over 2, because my output values are nice values to look at. So at sine, I'm starting here at 0. At pi over 2, so keep your unit circle handy, I come up to 1. At pi, we come back down here to 0. At 3 pi over 2, we are down here at -1. And then at 2 pi, we're back here at 0. Now, whenever I'm looking at this, I'm not going to do like pi over 4 is going to be the square root of 2 over 2. I'm not putting that in there, right? So any of these, we have all of the values that go between here, but these are the nice, easy ones for us to graph. So my sine curve is this nice, and I'm going to do like this because it actually continues on, right? So my sine curve is this nice curve, right? And it is periodic. When I'm looking at my sine curve, then this is going to be one period. It's a periodic function, right? So this is going to be one period. From there, then everything else repeats. So I could even go in this other direction. -pi, -3 pi over 2, and 2 pi. And I can go in another direction, and I could say, okay, no problem. I'm going to take this and extend it. I have one period and then it starts repeating. This can just keep going on and on forever. So here's one period. Here is one period. I can keep going to have another period. Keep going this way to have another period. It just keeps going on and on forever. So if we throw out some important features of sine, I know that one period of sine here is going to be 2 pi. I also know that my range is going to go from what to what? What's my high value and my low value? Yeah, so my range is going to go from -1 to 1. Good. It just keeps bouncing back and forth between the ones. And it is included because I have an actual value there at 1 and -1. What about your domain? Yeah, because it goes forever and ever, it is infinite. So this periodic function, I don't run out of those x values. It just keeps going on and on and on. And then I have this periodic function. All right? Okay, now let's take a look at good old cosine here. And then we'll make some comparisons. Y is equal to cosine of x. I'm going to do the same kind of deal. This will be 1, this will be -1, and I'm going to, so that we can compare them nicely. And these are also the nice values. That's it. When you look at your unit circle, what are the nice values that go with cosine? Also on our quadrantal angles, right? Those are the ones that are on the axes. Okay, so check it out. What happens if I'm looking at 0? Let's shoot back to our unit circle real quick. Oh my. Our unit circle tells us at 0 angle measurement, cosine is 1. Then it goes to 0, -1, 0, and then back to 1, right? So a full loop around is also going to give that. However, when I'm looking to loop this little fella around here, I'm starting up here at 1 because at the 0 angle measurement, it's at 1. At pi over 2, we go to 0. Pi goes down to 1. 3 pi over 2 is back to 0. And 2 pi is up here. Do you see that? So my cosine curve, there's one period of my cosine curve, and I'm going to take my arrow on down through there. Now the same thing applies with cosine. I can run cosine down through here. And I have another period. Do you see what's going on there? So if I'm looking at cosine from here to here, this is also one period of cosine. Meaning, if I'm looking at my specs here, the period of cosine is also 2 pi. My range of cosine is what? Yeah, -1 to 1. Same. What about my domain? Good job. It's also from -infinity to +infinity because it's infinite, right? I can do the same thing with cosine that I do with sine. I'm just running it around. Now, what do you notice about sine and cosine? They look real similar, right? It's this wavy curve, this sine curve, this cosine curve. There are a couple of little differences here. We know this is periodic and it doesn't technically start anywhere. However, take a look what's happening here at sine. Sine, and I'm going to put quotes around this because it's periodic, goes on forever, right? Starts at 0. Where cosine, if we're looking right here at cosine, cosine starts at 1. And that's the big difference. Sine and cosine basically look like the exact same curve, except cosine here is shifted pi over 2, really, right? So shifted here with this pi over 2 Otherwise, it would also look like your sine curve. Do you see that? Okay. So now let's take it back to what we know a little bit about functions, right? Our function, if I am reflecting around the origin, so if I put a pin right here and I swing sine around, do you see how it lands on itself? I have this and I swing it around and I have this. It lands back on itself. What did we say if I have a function that is symmetric about the origin? What was that called? An odd function. Sine is an odd function. All right. What did we say here if I have a function over here and then the mirror of it is on the other side of my y-axis? Do you remember what that one was called? It's an even function. That's going to make more of an impact later, but it's good to just put it out there right now. All right. So sine is an odd function. And cosine is an even function just because of its symmetry. All right. Now we're going to do the exact same thing with these functions because they are functions, right? We can look at the transformations and come up with, they're very similar. They have different names, but all of our transformations, a function is a function is a function, guys. So let's own this. So let's look at our let's look at our transformations here. So if I have, let's just throw it out here. Y is equal to C plus A. I'm going to use sine up front, but it can be any of them. B parenthesis X minus D. Now these variables are just ones that the book gives. They can be anything. Honestly, it doesn't matter. But these are just the variables in these same places that the book gives. So that's what I'm doing it so that it's consistency for you. This could be sine. This could be cosine. I mean, it doesn't matter. All right. So the transformations are just functions that we're talking about. All right. So previously, whenever we had these functions, if I am outside of my function, if I'm adding or subtracting outside of my function, what is that? Vertical, right? And this is a vertical shift. Same thing. Typically, we have this one in the back, right? Plus this, minus. But because I've got so much going on with my inside function, typically your vertical shift is in front. But it's still a vertical shift. And when I have this vertical shift, remember anything vertical is exactly what you think that's going to be. All right, now, what if I have a number that's multiplied by my function? What did we learn that to be? Learn that to be, oh my gosh. What did we learn that was whenever we talked about those? Ugh. Right, that's your vertical stretch and shrink. Okay, hopefully you guys are talking to me. I'm not just talking to myself. When I'm talking about trig functions, that's actually called an amplitude. It has a different name, but it literally serves the exact same purpose. This is the vertical stretch or shrink. Okay, that's what an amplitude is. It's your vertical stretch and shrink. If A is negative, what do you think is happening? If I have that negative amplitude or negative vertical stretch or shrink, what happens there? Yes, it's that vertical reflection. So I am reflecting over the x-axis. Exact same thing that you think would happen, right? So far, none of this is brand new information. We're taking previous information and putting it into this trig function. The only thing that's brand new is we're now calling our vertical stretch and shrink an amplitude. It's just a different word for the same thing. All right? Okay. Now, I'm going to change up my colors because I feel like this is getting bogged down here a little bit. This B, so that's all vertical. Red is vertical. Now let's look at what's our inside. So if we have inside function stuff, what does this deal with? Horizontal. Good. Now, when we have horizontal on this periodic function, our horizontal doesn't just move one little piece of it, it moves the whole thing. So when I'm moving that whole thing, this b value affects the period. Oops. Remember, it's this periodic function. It's this repeating function. So one period is one full function that we have, and then that is what's repeated over and over again. For the sine and cosine function, I know my period here is 2 pi. Whenever I do that horizontal stretching and shrinking, right? If I horizontal stretch and shrink, a shrink here for a period is what happens there. A stretch for my period is what happens there, right? It's just stretching that out. It affects the period. So I'm going to take my period of 2 pi and divide it by that value. That is what's going to help us. All right. My one period here, let's change our color a little bit up. Let's go for a nice little blue. So this is my one period, right? And this is my one period, and that's what stretches and shrinks out from there. Okay. And then lastly, I have this D. So anytime we add or subtract that D in there, yes, that's going to be my phase shift. It's called a phase shift, but it's horizontal shifting, right? In this, it's called a phase shift. Just like we get a new word for amplitude for the vertical stretch and shrink, this is a phase shift. It's still just a horizontal shift, and all the same rules apply.